So let us define a new concept. What is subsequence? The things that we are going to discuss from now are very interesting and very simple, and they may contain lots of information. So what's a subsequence?
Part of a sequence.
Part of a sequence. It means my sequence is 1, 2, 3 and so on. I pick up 2 from here, then I pick up
5,
4,
4,
then I pick up 8.
8.
This is a subsequence.
G,
The sequence is named as
N, B, N.
Anyway.
it should be related to n somehow. It should be related to n. I name this thing to be A, N, not exactly same, but I
Tilde. K, okay.
give another subscript A and K. This A N is your sequence. This A N with another subscript A and K is your subsequence. This will be part of this.
D.
This will be part of this always. Okay. But this thing can also be reformulated in another way. Let me tell you how to do that. What is your sequence?
3, 2,
This.
4. Increasing.
What is the first term of your sequence?
1,
Second term of your sequence?
2,
Third term?
3,
Fourth term?
4,
And in your subsequence, which term have you picked?
2,
You have picked
Second
One.
term.
second term,
Second term.
fourth term,
Fourth term.
eighth term.
Eighth term.
So you can say you have picked these terms 2 power k.
2 power k.
good.
So nk is replaced by 2 power k.
Power k, yes, yes.
I give you this sequence with the name n. I ask you to give me a subsequence
Subsequence.
a2 power k. What will you do? You will put k is equal to 1.
One. Starting
2
from-
power 1.
Yes, sir.
It means this becomes a2. So what you will do? You will pick second term
Yes, sir.
2. Then you will put k is equal to 2. This becomes 2 power 2. That becomes 4.
4.
So this whole becomes a4. You will pick fourth term.
Yes, sir.
Then you will pick eighth term, and so on and so forth.
G,
So this is how you define a subsequence.
G.
But what is this n?
Number of terms. Natural number.
What is this nk?
It is also,
It's not natural number, no? Because when you choose this set, this thing becomes 2, 4.
numbers.
These are not natural numbers. These are not all the natural numbers. Part of natural number. But what are these? Your n is what? A natural number. Your nk
NK.
is strictly
Yes.
monotone,
Monotone.
increasing sequence. Do you agree?
G,
So when you pick a subsequence from a sequence, the subscript you define is itself a sequence which is strictly monotonically increasing. Strictly monotone is okay. Increasing is okay. Do you agree with this thing?
D,
So you can do this thing easily. I want you to tell me one thing else. My sequence is minus 1 power n. The first term would be minus 1 plus 1 minus 1 plus 1 minus 1 and so on. The question is this a sequence?
yes.
Is this convergent sequence?
No.
Is this bounded sequence?
Yes.
Yes, yes, yes.
Now I take these terms. What do you mean by this?
Just multiply.
Put k is equal to 1, this becomes 2.
Second
Put k is equal to, this becomes 4.
4.
Then 6. So what you have to do? You have to take second term. Look at this one. Second term, fourth term,
Yes, sir.
sixth term. It means all the even terms.
Even terms.
So what are those?
1,
Even terms 1,
1, 1,
1. So even terms are these. This is subsequence for this.
But
Do you agree?
Yes.
Give me this. 2k minus 1.
Odd terms.
odd
Or odd terms.
Odd terms.
It means
Minus 1,
minus 1, minus 1, minus 1 and so on.
Just splitting into two parts.
Into two parts.
but not struggling.
Now they are the. Wow.
Not struggling.
Is this a convergent sequence?
No.
Is this convergent?
Yes.
This converges to
One.
1, 1, 1, 1.
Yes, sir. One.
Is this convergent?
Yes.
Yes.
Converges to minus 1.
Minus one.
A constant sequence is always convergent
Constant sequence.
to the value that it contains.
Content,
Same way. This is also constant sequence. So there is a sequence which is not convergent, but its subsequences are convergent.
Or convergent.
Why? Is it possible always?
Not necessarily.
Not necessary. So what is the condition? You can see this is a sequence which is not convergent, but it has certain subsequences which are convergent. Sequence is not convergent, subsequences are convergent. What is the condition that relates these two ideas? The condition that relates is boundedness.
Boundedness.
Boundedness. This is not convergent, but bounded. So if a sequence is bounded,
Yes, sir.
then it has certain subsequence that might converge.
Yes.
So sequence is bounded, then it has convergent subsequences. It itself is not convergent. Okay, so let us discuss certain definitions.
That's the beauty of subsequence.
Subsequences. But what if a sequence that we take is convergent? 1, 1 over 2, 1 over 3, and so on. Is this convergent?
Yes.
Yes.
Where does it converge?
Zero.
0. We know very well. 1 upon 3, 1 upon 4, decrease is 0.
Yes, sir.
I take 2 power k.
All even terms.
It means I take 1 upon 2,
So, half.
1 upon 4,
Yes, sir.
1 upon 8.
Eight.
Is this convergent?
No. You zero division.
Convergent to 0?
Zero, zero.
Convergent. If you take any other subsequence, so if a sequence is convergent to some limit a, then it's all these subsequences will converge to the same
To the
limit
same limit.
a.
Yes.
That's the result.
Yes.
So we can call it a theorem. An is convergent to limit a, then all its subsequences converge to same limit. What does it mean? Limit n goes to infinity, a n k. A n k means subsequence
Yes, sir.
is always also
A.
A.
the sequence is convergent. Its all subsequences must converge. We have taken this sequence which is not convergent, but this subsequence converges to 1, this subsequence converges to minus 1. We call this 1 to be an accumulation value of our original sequence an. We call this thing also an accumulation value of our original sequence an. So our original sequence is an, which is not convergent but bounded. We took its two subsequences one subsequence converges to 1, another subsequence converges to -1. These two are called accumulation values of our original sequence. We are going to define what an accumulation value is,
Yes, sir.
but this is just an example.
G.
How many accumulation values?
2.
1 and -1. Let us come to this idea. What is our sequence? N. What is the limit?
0.
0. What is the subsequence?
A power
A
2k.
power 2k.
What is the limit?
0. Same.
You take all the subsequences of this sequence.
Yes.
The limit of all those subsequences would be same.
Same.
G.
Same.
Okay. So this 0 is called accumulation value. You take another subsequence. What would be limit?
0.
0. You take another subsequence. What would be limit?
0.
So these all are accumulation values for original sequence.
Collecting all the values.
Yes. But if accumulation value of a sequence is unique, then the sequence is convergent.
G.
Convergence.
You can say accumulation value will be only 0 in this case.
Yes.
You take any subsequence, it will converge to 0.
Yes, sir.
If there are accumulation values which are more than 1,
More
Then
than
it is not.
then it will not be
Convergent.
convergent.
G. G.
So we are going to relate convergence with accumulation values.
Wow. Wow.
Let's write the definition of accumulation value from different from the traditional definition that we write. It is some other words what we call cluster point, limit point,
G.
accumulation point, also called partial limit. So let us write these names first. So accumulation value, also called cluster point, or also called partial limit, and another word is limit point. So this is what we call the limit point of a sequence, and the cluster point of a sequence, the partial limit of a sequence, or the accumulation value of a sequence. So definition: A is called an accumulation value of a sequence an if what happens? If there is a subsequence A and K where what is K is a natural number,
Natural number.
converges to
Some way
converges to A.
converges to.
This A is accumulation value.
Yes, sir.
If you pick a sequence, it is a subsequence which converges to A. Then A is called accumulation value, also called cluster point, accumulation value, limit point, partial limit.
Limiting amount of a subsequence.
What is the alternate definition? So A is called accumulation value of an if for all epsilon positive, epsilon neighborhood of A contains infinitely many terms of this is another definition where we are not using a subsequence. You can see I have not written any word such like subsequence in this way. This is the traditional definition that we use when we discuss accumulation point or limit point of a sequence. Are you okay with this example?
Yes.
This example,
Fine.
This theorem is okay. This definition is also okay.
Okay.
Let us discuss this definition. So what is the definition? A value is called accumulation value of a sequence if what happens?
Epsilon covered.
So my sequence is minus 1 power n. How many accumulation values? 2. 1 and minus 1. It means the first term of your sequence is minus 1. Second term,
1
then
minus
1. Minus 1, 1. Minus 1, 1. Minus 1, 1. Now why this 1 is an accumulation value? Because you take any epsilon neighborhood, inside this neighborhood there are infinitely many terms of the sequence. The second term of a sequence lies here. Second term is 1. Fourth term is 1. Sixth term is 1. Eighth term is 1. So around this neighborhood you have infinite terms. Even around this neighborhood you have infinite terms. So this value is an accumulation value. This value is also an accumulation value for this sequence. Okay, let us combine bounded sequences with convergent subsequences with the help of accumulation values by using a theorem with the name Bolzano-Weierstrass theorem. So whatever we have discussed, we are going to write this thing in the form of a theorem with the crazy name Bolzano-Weierstrass theorem. These were two mathematicians. Yes. Basically these were physicists in past. But now we have current mathematicians who are purely in the field of mathematics, but in past they were physicists basically. So the theorem is if you have a bounded sequence, and you know very well what do you mean by a bounded sequence. It implies what happens. If a sequence is bounded,
This lower bound, upper bound.
yes, it implies an has an accumulation value.
G.
So this is the statement of Bolzano-Weierstrass theorem. Give me a bounded sequence, then I will always give you an accumulation value of that bounded sequence. The good example is this. The sequence is bounded, it is always accumulation value. A sequence might have one accumulation value, might have two, might have none.
G.
A sequence might have one accumulation value like we wrote here. The accumulation value was 0. And if it has one accumulation value, it is called convergent. A sequence might have two accumulation values, or a sequence might have no accumulation values.
G. 1, 2, 3, 4, 5, 6.
Yes, yes. But mainly these are most examples, either 1 or 2 or none. And 2 can be mostly 1 or minus 1, 2 and minus 2, 3 and minus infinity, minus 3, up to plus infinity and minus infinity. Yes. This sequence has two accumulation values, 1 and minus 1.
Yes, sir.
And this sequence has two accumulation values, plus 2 and minus 2.
Plus 2 and minus 2.
G.
Plus 2 and minus 2.
Same case goes for n.
Same case. So, what I was supposed to say?
None accumulation value.
Yes. None. This is the example, no?
Not bounded.
Infinite.
And also not
Not
convergent.
convergent.
Not convergent and also not bounded.
Yes, it is not convergent, not bounded.
G.
Boundedness will guarantee there is an accumulation.
Yes, sir.
value.
Yes, sir.
So,
Boundedness will guarantee.
hypothesis.
If it is not bounded,
Yes, sir.
cannot have any accumulation value, this theorem says. Or the reformulation of this theorem is An is bounded, it implies An
Here's accumulation.
has a convergent
Convergence.
subsequence. If it has an accumulation value, obviously it would be having a subsequence
Yes, sir.
which will converge.
Convergence.
Obviously. So you call this is the statement of the theorem,
Theorem.
or this is the statement of the theorem. Both are equivalent things.
There is a concurrent.
ಅಲ್ಲಿ pure ಇದರಲ್ಲಿ ಚೆಕ್ನ ಇಂಟ್ರೆಸ್ಟ್ ಇದೆ समझे pure में डिस्कस में थी point थी divergence welcome
Divergent sequences. There are two cases. A sequence An divergent plus infinity. And the second thing is An, a sequence that diverges to negative infinity. Okay, the example for this one is An is equal to n,
n opposite bound
and for this one the example is An is
minus
minus n. So these are very good examples.
yes sir
One sequence is 1, 2, 3 and so on. This goes to positive infinity.
yes sir
Another one is minus 1, minus 2, minus e goes to negative. How do we define this thing? I say a sequence diverges to plus infinity
if it is not
if
bounded
and only if what happens?
it is not bounded above
It's not bounded above. Yes?
It's not a bound.
Yes, it is not bounded. It's okay. But can we define it using some sort of epsilon delta definitions? Using epsilon. So when I write this thing, it means this thing is similar to this and this thing is similar to this. When I give two dots here,
Defining.
it means I am going to define this thing in this way.
yes sir
So I am going to define it. So your sequence is this 1, 2, 3, 4, 5 and so on.
yes sir
Now how can I define this? That your sequence diverges to plus infinity if for all C positive. For all C positive. It means
Define this notation. Two dots and
this is implication, means this is equivalent to this and this is equivalent to this. But when I define this thing in this way, I always give implication with two dots.
two dots
This is the definition. So I say that my sequence goes on and diverges to plus infinity. It means I ask you to give me any value C. Give me any value C. If I write epsilon, it means I say give me any smallest value. If I write something else like C or D or whatever, it means give me any large value.
any large value
Any large value.
any large
Like you give me 1 billion, 1 trillion. After this thing, there would be some terms of my sequence. You give me the value of C to be in trillions and quadrillions and zillions. The terms of my sequence will be even beyond than that. I call this thing to be divergence to plus infinity.
divergence to plus infinity
So I tell you, give me any positive number, very very large. The terms of my sequence will be,
Even greater than that.
using n would be good, yes, greater than this, when there exists some instant and whenever you go beyond this instant, this happens. It means when my sequence will be having terms greater than your C, when this n goes beyond a fixed value capital N.
Game period.
It means I give you this sequence. The sequence is same an. I say this diverges to plus infinity.
जी
How? You will give me the value of C to be 10 power 10 power 10 power 10. 1, 2, 3, 4, 5. Let's say C is this. You give me this C, and I will say that the terms of my sequence will even go beyond your C.
जी
And what is this N? Just let me write C plus 1.
C plus 1.
जी
Yes, sir.
वाह
Anything C plus 1.
Yes, sir.
So, you give me any fixed value, the terms in my sequence will be beyond that. Always. I call this thing to be divergence to plus infinity.
Plus infinity, yes.
What do you mean by divergence to minus infinity? How will you reformulate this? For all C positive,
just
or should I write C negative? Keep it this same. Just change this thing.
जी है
The terms of your sequence are less than negative C. Because you are saying that your sequence diverges to negative infinity. Your C is positive. When you take it negative C, it becomes a very large number in negative sense.
Negative sense.
And all your terms of sequence are less than negative C. It means it diverges to minus infinity.
Minus infinity.
So this is definition for divergence to minus
Minus
infinity. And these things are sometimes asked in exams. It is not always that you are asked these things, but they may ask you, okay, a sequence diverges to plus infinity. If for all C there exists, then they miss this condition and they give you some 3 to 4 options that what happens. What is going to be the good condition for divergence? Then you should be okay, AN is greater than C, then it diverges to plus infinity. If AN is less than minus C, then it diverges to minus infinity. So these are two definitions for divergence. Let us close this after 10 minutes,
Yes.
because let me just discuss one or two things with you. And next thing is lim sup and lim inf. It means limit superior and limit inferior.
Inferior.
But if we are going to discuss this thing right now, it will not be good. Because if you are going to discuss, then we should discuss their theorems as well. But discussing their theorems and examples will take a lot of time. So let us leave this thing to the next class, but we are going to complete this idea. Okay, we have divergence as well as convergence. Sorry, divergence to plus infinity and divergence to minus infinity. We have discussed both things. Okay, if a sequence is not bounded from above, it means what happens? It diverges to
minus infinity
plus infinity.
Yes, sir.
A sequence is not bounded from above, so it diverges to
Plus infinity.
plus infinity. And we call plus infinity to be improper
Improper.
accumulation value of AN, which is not bounded above. So we have a sequence which is not bounded above.
Yes, sir.
We call plus infinity to be its accumulation value, but we call it improper accumulation.
Yes, sir.
It's just notation we are supposed to keep in our mind. Then what is minus infinity?
Also improper. But
Improper accumulation value of a sequence which is not bounded below.
below. Yes, sir.
Which is not bounded below.
Below.
So we have this sequence which is not bounded,
Above.
not bounded above.
Yes, sir.
Then we say that it has
An Improper.
no proper accumulation value, but it has one improper accumulation value, that is plus infinity.
Infinity, yes, sir.
And we have this sequence
Uh,
whose minus infinity is improper accumulation value. So sequences might have proper and improper accumulation values, and improper accumulation values are plus infinity
and minus infinity.
and minus infinity. Can a sequence have both plus infinity and minus infinity as its accumulation values? Give me any example of a sequence with two accumulation values. Both are, one is plus infinity, other is minus infinity.
Set of integers.
Set of integers. But give me in the form of mapping or a sequence. Set of integers, you are okay with that. It goes plus infinity, minus infinity.
n power minus 1 upon n. N minus 1 power n.
It is defined in this case. N times,
What about this?
yes. It has two accumulation values.
Yes,
One
sir.
is plus infinity, other is minus infinity. Because this thing increases, but increases in both directions.
Both cases. Both
Like
ways.
minus 1, plus 2, minus 3, plus 4, and
Yes.
so on. So it has two accumulation values. Both are improper. One is plus infinity,
Yes, sir.
and other is minus infinity.
डॉक्टर जावेद इकबाल तो उदा जमा पढ़ो ना ना कावड़े तो बोल
Okay, so any question?